Today we looked at the basics of absolute value. So now let's look at solving equations using absolute value. So make sure you title your notes. And let's just review briefly some of the basics. So graph the following absolute value equation. What do you notice? Recall that the absolute value of 3 is 3 units. So the distance from 3 to 0 is 3 units. Likewise, the absolute value of negative 3 is 3. So the distance from 0 is 3 units. And recall that distance is always going to be positive. So let's look at some basic equations. We know that the absolute value of 2 is equal to 2, and the absolute value of negative 2 is equal to 2. So that means that this expression, x minus 1, has to equal 2, or it has to equal negative 2. What's inside? So 3 minus 1 gives us 2. Likewise, negative 1 minus 1 gives us negative 2, which the absolute value of negative 2 is equal to 2. So it's really important in math to notice patterns. So let's look at the pattern that we see. The distance from 1, in this case, is 2 units. Okay? The distance from 1 is 2 units. If we look at this one, 5 minus 3 gives me 2, and 1 minus 3 gives me negative 2. So in this case, the distance from 3 is 2 units. Okay, so how does that work? What if we don't have a graph present? What we're going to do is we're going to rewrite this equation to account for both the positive and negative values. So recall that the absolute value of 17 is 17, and the absolute value of negative 17 is 17. So we have f plus 5 needs to equal negative 17, or f plus 5 needs to equal positive 17. So this expression, what's inside of the absolute value symbols, needs to equal 17 or negative 17 in order for the equation to equal 17. So now we're just going to solve the equation. So we're subtract 5 from both sides. So we have f plus 0 is equal to negative 22, and f is equal to negative 22. We're going to subtract 5 from both sides, and f plus 0 is equal to 12. So f is equal to 12. And we're going to use set notation for this. So f can equal 12 or negative 22. Okay, and we use brackets that look like this so that we don't get confused thinking that this is a point on the plane or an ordered pair. So we don't use parentheses, we actually use brackets. Take a look at this problem. Do you see an issue with this? Is there anything that we can put in for b that will make this equation true? If I put 4 here, I get 4 minus 1 is 3, and the absolute value of 3 is not equal to a negative 3. If I put in a negative 2 here, I get a negative 3, but the absolute value is always going to be positive. So for this particular problem, there is no solution. Anytime it equals, you have an expression, an absolute value expression that's equal to a negative number, that won't work. So solve each equation, then graph the solution set. So I want you to practice this particular problem. So put the video on and pause, and we will go over this problem tomorrow. Now let's look at an application problem. So a standard adult tennis racket has a 100 square inch head, plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of the adult tennis racket. Let's let x equal the size of the tennis racket. So we're going to have absolute value. We have x minus 100. That's our base unit. Okay, that's what we're judging. What varies, okay, is the 100, and that is equal to 20, which is the range, how much the base value varies. Okay, so let's solve that. We have x minus 100 is equal to negative 20, and x minus 100 is equal to a positive 20. And notice when I rewrite these, I'm not using the absolute value bars anymore because I'm accounting for the absolute value by having the two equations. So we're going to add 100 to both sides, and x is equal to 80. We have x is equal to 120. So the racket has a least value of 80 inches and greatest value of 120 inches. So to help you remember this, there's a basic equation for absolute value, and we have our variable minus whatever that central value is, the base value, is equal to r, the range, how much it varies. So like in the last problem, x minus 100 equals 20. So now I'd like you to try this one. The temperature of an enclosure for a pet snake should be about 80 degrees, give or take 5 degrees. Find the maximum and minimum temperatures. So I have this diagram to help you, but I want you to write the equation for this particular problem. We can also apply this to abstract situations, and we're going to look, we have 11 and 19. So what's the central value? What's the middle of those two numbers? And that would be 15. So we have the absolute value of x minus 15 is equal to how many units from 15 is 19? Well, that is 4 units, and it's also 4 units here. So your last challenge is to write an equation involving absolute value for this particular graph.